Hello ladies and gentlemen, welcome to my video. This is today's question. It looks quite simple, but it cannot be solved using simple or direct substitution methods. It requires other strategy and more than one substitutions. Let's label Q as equation 1. Apply changing sign of variable strategy. Change the x become negative x. Therefore, dx become negative dx. 1 become negative 1. Negative 1 become 1. X power 2 is still x power 2. Q become integral 1 to negative 1. Numerator is 1 minus x power half, while denominator is 1 minus x squared power quarter, and then multiply negative dx. As usual, we can cancel the negative by swapping the integration bound. Label it as equation 2. Now we can apply equation 1 plus equation 2. Left hand side is 2q, but we bring the 2 to the right hand side become 1 over 2. While for the integrand, the numerator is 1 plus x power half plus 1 minus x power half. Denominator and the integration bound remain the same. Let's do the first substitution. Define x equals to cosine 2u. dx equals to negative 2 sine 2u du, which is equals to negative 4 sine u cosine u du. From here we know u equals to half inverse cosine x. When x equals to 1, u equals to half inverse cosine 1, which is 0. When x equal to negative 1, u equals to half inverse cosine negative 1, which is pi divided by 2. Meanwhile, 1 plus x power half equals to 1 plus cosine 2u power half. Using double angle identity of cosine 2u, and then we convert the 1 become sine square u plus cosine square u. The 1 plus x power half become 2 cosine u power half. From the integration bound, which is pi divided by 2 to 0, which is in quadrant 1, we can cancel the cosine power 2 with the power 1 over 2, become square root of 2 cosine u. For the 1 minus x power half, again we apply double angle identity of cosine as well as Pythagoras identity. It is equal to square root of 2 sine u. 1 minus x squared power quarter is equals to sine squared 2u power quarter, which is equals to 2 sine u cos u power half. Of course, we can take out the constant 2 becomes square root of 2, while cos u multiply sine u power with half. Now we have all necessary equations and new integration bounds for us to write the new Q. Q become 1 over 2 integral pi over 2 to 0 square root of 2 sine u plus cos u divided by square root of 2 multiply sine u multiply cos u, and then the whole thing power 1 over 2. Multiply negative 4 sine u cos u du, which means Q is equals to 2 multiply integral 0 to pi over 2 sine u plus cos u, and then multiply sine u cos u power 1 over 2 du. Another round of substitution. Define t equals to sine u minus cosine u, which means dt equals to cosine u plus sine u, and then the whole thing multiply du. So we can see that this two part of the Q has been replaced with dt. For integration bound, when u equals to pi divided by 2, t equals to 1 plus 0, which is 1. When u equals to 0, t is equals to 0 minus 1, which is negative 1. But there is still one part in Q that we haven't changed to t. How do we do that? Don't worry, we can do that. From t, we know t squared equals to sine square u minus 2 sine u cos u plus cosine square u. We know that sine square u plus cosine square u is equals to 1. And from here, we obtain sine u multiply cos u. The whole thing, power 1 over 2, is equals to square root of 1 minus t squared and then divide by 2. Combine all info, we know Q equals to 2 multiply integral negative 1 to 1 square root of 1 minus t squared divided by 2 and then dt. Take out the 1 over square root 2 as a constant put in front. The integrand becomes square root of 1 minus t squared. This is interesting. The integrand is actually a semicircle equation centered at 0, 0 with the radius equals to 1.0. Which means Q is equals to 2 divided by square root of 2 and then multiply the area of this semicircle, which is equal to 2 divided by square root of 2 multiply 1 over 2 multiply pi and multiply 1 power 2. Interestingly, we come to the final answer of the question by changing the sign of the variable, 2 round of substitution and area of semicircle. The final answer equals to pi divided by square root of 2. Thank you for watching this video until the end. Please continue support my channel, subscribe, give a like and share my video in your social media. I may not upload new video in the next 2-3 days, so I see you next Monday or Tuesday. Bye bye.